Namaste children. So we completed exercise 1.2. So before going to next exercise 1.3, let me recall you what are irrational numbers and what are co-primes. So as you learnt in 9th standard, what are irrational numbers? Numbers which cannot be written in the form of p by q are called irrational numbers. For example, root 2. Root 2. 2 is not a perfect square. So as you learned in 8th standard, when you do root 2 long division method, division will continue. There is no end for division. What type of decimal you will get? Non-terminating, non-repeating decimals. These are all non-terminating, non-repeating decimals. So we cannot convert them into p by q form. Therefore, they are called as irrational numbers. Next, co-primes. I think this about co-primes you have learned in 6th standard. Any two numbers are said to be co-primes. Co-primes means the numbers need not be prime. Any two numbers, I have mentioned you, any two numbers are said to be co-primes if their HCF is 1. Their HCF means highest common factor is 1. For example, 2 and 9. 2 is a prime but 9 is not a prime. So that I told you any two numbers. 2 is not divisible by 9 or 9 is not divisible by 2. Therefore, their HCF is 1. So 2 by 9 is in simplest form. 24 and 7. Here also HCF is 1. So therefore 24 and 7 are co-primes. So with the help of definition of co-primes and irrational numbers, now let us move for the next topic, that is exercise 1.3. Question number 1. Prove that root 5 is irrational. Before I start, root 5 is irrational. So let me explain one theorem in your NCERT book, that is Theorem 1.3. Let p be a prime number. If p divides a square, then p divides a. If p divides a square, then p divides a. Let me explain this with one example. Let me take 3. What is 3 here? 3 is a prime number. So let p as 3. 3 divides 9 square. So what is a here? A as 9. 3 divides 9 square. So consider 3 can also divide 9. Yes, 3 divides 9. So like this you can take many examples and try to understand what is the concept behind this theorem. That is, any prime number, if p divides means what? A square is divisible by p. Similarly here, 3 divides 9 square means 9 square is what? 81. 81 is divisible by 3. Instead of writing 81 is divisible by 3, you can write in this way also. 3 divides 9 square. So when 81 is divisible by 3, so that is 9 is also divisible by 3. So using this concept, we try to prove that root 5 is irrational number. As everyone know already in 9th standard you learnt that root 5, that is 5 is a non-perfect square. So 5 will be irrational, but we have to prove it theoretically. So before I start proving, let me explain the method of contradiction. So we use the method of contradiction to solve certain questions which we cannot prove directly. So this method we already learnt in 9th standard. So what is the method contradiction? We assume that any question will take, we assume a wrong assumption, and finally concluding that what our assumption we have taken is wrong. Means we prove that our assumption is wrong. So that is called method of contradiction. So this question also I will try to solve the method of contradiction. Let us assume that root 5 is rational. He asked to prove irrational, but I am assuming, as you all know that I am assuming wrong assumption. Let us assume that root 5 is rational. So as all of you know, what is the definition of rational number? Rational number is a number which can be written in the form of a by b, that is p by q form, that is which can be written as a fraction form. So when we assume that root 5 is rational, then I have to write root 5 in the form of fraction, that is p by q form. Then there exist two co-prime numbers. So I took that why I took two co-prime numbers. In the last I will explain why I have taken co-prime numbers. So when we take co-prime numbers, that is a and b, such that root 5 equals to a by b. Because a and b are co-prime, so you know that when they are what is the definition of co-prime? A and b are co-prime if their HCF is 1, means I cannot cancel further. So a is not a factor of b is not a factor of a. So that's why we tell that this is already in simplest form. What is meaning of simplest form? So suppose if you take 3 by 21, so this is not simplest form. You can cancel 3 by 21, that is 3 ones are 3 sevens are. But 3 by 10 is in simplest form. Why? 3 and 10 we cannot cancel because HCF is 1. So 3 and 10 are here co-primes. So why I have taken co-prime numbers? Because this is to show that my fraction is already in simplest form. So let me continue. B, cross multiply this, we get root 5b equals to a. Square on both sides. Root 5b whole square equals to a square. So root 5 into root 5 is what? 5. 5b square equal to a square. So what is the meaning of this? Again you have to go back to Euclid division lemma. So when a square is divisible by 5, what is the quotient? B square, remainder is 0. So how will you write using lemma? A square equals to 5 into b square. So that only I have written here. A square equals to 5 into b square. So that means that a square is divisible by 5. So when a square is divisible by 5, a is divisible by 5. Just now I explained theorem 1.3. When p divides a square, then p divides a. So same thing I am applying here. When a square is divisible by 5, as you know that 5 is a prime number. When a square is divisible by 5, then a is also divisible by 5 by theorem 1.3. When any number is divisible by, suppose a is divisible by 5, what is the meaning of that? Remainder should be 0. Then there will be some quotient. So let us consider our own quotient. Then there exists some quotient c such that a equal to 5c. So to understand you, I'll explain. So in this method, when a is divisible, I wrote here a is divisible by 5. A is divisible by 5 means remainder should be 0. So I have taken quotient as c. So again apply the lemma and write a equals to 5 into c. So this only lemma tells you a equals to 5c. Take this as 2 and take this as 1. Now substitute this 2 in 1. So substitute 2 in 1. 5b square. So in place of 1, that is in place of a, you substitute as 5c. 5c whole square. 5b square equals to 25c square. Cancel this. 5 ones are 5 5s. B square equal to 5c square. So again the same repetition. Again what is the meaning of this? B square is divisible by 5. That is remainder is 0. C square is the quotient. So once you check the lemma, b square equals to 5 into c square. B square equals to 5 into c square. This means b square is divisible by 5. Again by using theorem 1.3, b is divisible by 5. Now I proved a is divisible by 5 and also I proved b is divisible by 5. Means what? Here in starting I assumed that a and b are co-primes. What is the meaning of co-primes? A and b, HCF is only 1. But what I got here? A is divisible by 5 and b is also divisible by 5, means I proved that a and b as a common factor as 5. So this mismatches, that is my assumption is wrong. I assumed that a and b have, therefore a and b have 5 as a common factor. I proved from this process a and b have 5 as a common factor. But this contradicts the fact. What was the fact? What I assumed? A and b are co-primes. Means a and b has no common factor I assumed. But I proved that a and b has a common factor as 5. So my assumption is wrong. So this shows that we cannot assume this. This is wrong assumption. Hence root 5 is irrational number. Thank you.